Welcome to Microlecture 55, the last alkene addition reaction that we cover, and it's ozonolysis. Okay, so when adding ozone across an alkene, we don't have to think about mechanism at all. We're just predicting products. And so this is just another tool for our arsenal of different chemistries that we could do for synthesis. So let me give one example, and we'll do a couple of more complicated ones. In these problems, it's going to be a good idea to count carbons and maybe number them so that you keep track of all of them. The reagent set is ozone, and then that's followed up with zinc and HOAC as it's abbreviated, which is just this. When you see O3, you know it's ozone, and this is going to be an ozonolysis. The lysis part on ozonolysis means break. And so we are breaking the carbon-carbon bond right in half, right there. And we're generating carbonyls from each side. So let's go ahead and number the carbons. Let's say 1, 2, 3, 4, 5, and 6, just to keep track of all of them in the product. So this side of the product is going to form a double bond to oxygen, where this is carbon 1 and this is carbon 6. The other side is going to generate a double bond to oxygen as well. So this is carbons 3, 4, and 5. And carbon 2 is right here. So carbons 2 and 3, which were our carbon-carbon double bond carbons, become our carbon-oxygen double bond carbons. All right, and so we generate two products. For every alkene that we have in the structure, we're going to have two products. We're also only going to generate ketones and aldehydes. This one is a ketone, this one is an aldehyde. And you'll know because if you have two R groups on the carbon, you're going to generate a ketone. And if you have a hydrogen, which we do, I can label it for clarity, then you're going to generate an aldehyde. Okay, so a couple more that are a little bit more complicated. Like if you put the double bond in a ring, then technically you don't get two separate products. The ring just opens up. All right, and so let me draw the reagent set. Again, we're going to break this carbon-carbon double bond in half. Let's go ahead and number the carbons just for clarity. We're going to have this ketone, and then I'm going to count 1 from carbon 3. 1, 2, 3, 4. And on that carbon, I'm going to have another carbonyl. That carbon is attached to a hydrogen. That side is an aldehyde. And I'll just number the carbons to make sure that I haven't messed up. And so that's the expected product there. So one molecule because the ring just cleaves and opens up. Now what happens if we've got more than one double bond? All right, so both of them are going to cleave. Super important to number so that we don't lose any carbon atoms. So that's going to be carbon 3, 4, 5, 6, 7, 8, and then we've got some methyls, 9 and 10. All right, and so I'm seeing this carbonyl, and I can orient them kind of how they are in that drawing so that it's intuitive. And then we've got a third molecule right there. And so just to make sure, go back and say, okay, this was carbon 1, this was carbon 2, 3, 4, and 5, 6, 7, and 8. I had a methyl there and a methyl there, so that's 9 and 10. So kept track of all the carbons, but 3 products here. All right, so a little aldehyde, a product with 2 carbonyls in there. On one end it's a ketone, on the other end it's an aldehyde, and the last product here is a ketone.